Hello everyone, and welcome to Biopedia. When discussing genetics, people often bandy about the phrase inbreeding coefficient, which is essentially a mathematical way of expressing how much inbreeding there is in someone's ancestry. As an example, Charles II of Spain had an inbreeding coefficient of 0.254, which is actually higher than the 0.25 which results from the children of a sibling or parent-child union. Now, I won't go into the details of Charles II's ancestry here, but have a look at his Wikipedia page if you're interested in the detail. Suffice it to say, it's quite a messy tree, and Charles II was not a healthy man, dying at the age of just 39. Again, I'm going to leave the specifics of his conditions for another time, but as a sample, he'd been unable to walk until the age of 8 to 10, and in Spain he is known as the Bewitched. Now, there are people who have calculated figures like this for other individuals. For example, there is a blog post which informed me that Danaerys Targaryen from Game of Thrones would have an inbreeding coefficient of 0.375. But how was this figure calculated? Although I haven't been able to figure out exactly how it works for more complicated puzzles, such as Daenerys Targaryen or Charles II of Spain, I'm going to take you through the process for some simpler examples, using a method I learned from a blog I'm putting a reference to in the show notes. Please note this is a guide to the method, rather than a discussion of the impact of inbreeding on particular families. However, if this is something you would be interested in, I have found some papers which reconstruct the diseases suffered from by the Ptolemies of Egypt using their symptoms. There is also the aforementioned case of Charles II of Spain, so if this is something you'd be interested in, feel free to let me know in the comments. So, let's try and work out the inbreeding coefficient of the following two individuals. And you might want to make a drawing here, but I'll try and explain it as clearly as I can. So first, we have individuals A and B. They marry and have children C and D. C has 3 children, E, F, G, and D has 2 kids, H and I. Now notably, G and H, who are first cousins, marry each other and have 2 children, J and K. It is these two, J and K, who we're going to be trying to calculate the coefficient for. The first thing we need to do is find the first inbred individuals in the family tree. In this case, J and K, as their parents, who were, remember, G and H, share a set of grandparents and therefore a set of common ancestors. Once we've found them, we need to go up and back down the family tree to count the number of steps between the two parents. So, start with G. There is 1 step up to their parent of C. Step 2 goes to A and B, the original grandparents. Step 3 takes you back down to D, their other child. And step 4 brings you down to H, who married their cousin G, and had J and K. So, in this case, we would need 4 steps through the grandparents A and B to get from G to H through the family tree. Now for the first bit of our equation. Take the number of steps we just did and add 1. You might now be breathing a sigh of relief at this point, but we're sadly not done. Now you need to raise 0.5 to the power of this new number. So for our example above, we had 4 steps, add 1 we get 5, and 0.5 to the power of 5, or 1 over 32, is 0.03125. This new number now needs to be doubled. Why? Well, the exact same route that we outlined earlier with 4 steps can be taken through both parents. Because you can start at G or you can start at H and effectively end up in the same place. Notably, this wouldn't be the case if, for example, J and K were related through half-siblings, as you couldn't do 2 perfect loops in this manner. So, the number you end up with is 0.0625, or 6.25%. So, the coefficient of inbreeding for 2 individuals born from a first cousin union is 6.25%. Now remember, full sibling or parent-child unions have a coefficient of 0.25 for comparison. But we can go further. What if the children of J and K, to clarify, children by different people, let's call these kids M and N, marry and have children of their own, so repeating the first cousin pattern? How will this impact the inbreeding coefficient of their child, let's say individual P? And yes, the letters are a bit random. This is because I'm adapting from a blog post I did where I had a more detailed family tree with extra siblings with extra letters. But the point is, we have individual P, born from a first cousin union, and their great-grandparents were also first cousins. So first off, go through the same process again for these new parents M and N. Just as we did last time, you end up with 1/32 for this loop of 4 steps. Double it as before because you can get there twice, and you end up with 1/16. However, now we need to go through some more steps. We need to add 1 to this 1/16 we got last time to get 17/16. This might not seem logical at the moment, but bear with me. The reason we're doing this is that this second set of parents don't start off with, if you like, a clean slate. They are, after all, inbred themselves, given the marriage of individuals G and H back in the day. So, the equation for this second set of inbred parents is accordingly more complicated. You need to multiply the number you would otherwise get if it were a clean slate, so 1/16 for our purposes, by the 17/16 we just got, and then multiply all of that by 2. Why do we double it? Well, because the number of roots you can take back to the original common ancestors A and B has doubled. Both M and N can trace their lineage back to them via both G and H. So you don't end up with 2 pathways, you end up with 4. Now for the final step, I promise. We now need to add these 2 numbers together, the original number we got for G and H, and the second number we've just calculated for P. So, adding all of this together, you get 1/16 plus, and then you open the bracket, a 16th times 17/16 times 2, which equals 0.1953125. And incidentally, I will not be summarising the mathematical equation I put up on the website, as I'm hoping to retain at least a little bit of your collective sanity. However, that's the process, more or less simply explained. I hope that was clear. Here's hoping that I've managed to explain all of this correctly, as truth be told, it took me quite a while to get my head around it. If not, feel free to let me know, and I'm sure we can revisit it in a future episode. However, for now, that brings us to the end of today's episode. As always, thank you all for listening. Feel free to get in touch with the show's email address if you have any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.